Welcome back to our channel Cosmic Earth. Today we are exploring one of the most terrifying cosmic incidents in modern history. On June 30th, 1908, a massive explosion rocked a remote region in Russia. The blast was so powerful it flattened millions of trees in an instant. Imagine an explosion 1,000 times more powerful than the Hiroshima atomic bomb. Yet, there was no crater left behind. This mystery has kept researchers searching for answers for over a century. Let us dive into the strange reality of the Tunguska Event. Local eyewitnesses reported seeing a massive blue light moving across the sky. The light was almost as bright as the sun itself. Seconds later, a shockwave knocked people off their feet hundreds of miles away. The heat was so intense that people felt their clothes burning. Seismic stations across Eurasia registered the massive shockwaves from the impact. Even barometers in the United Kingdom detected the sudden change in atmospheric pressure. For several nights after, the night sky over Europe was bright enough to read by. This strange glow was caused by dust high in the atmosphere reflecting sunlight. The blast occurred near the stony Tunguska River in Siberia. This region is incredibly remote and covered in dense swampy forests. Because of the isolation and political turmoil in Russia, no scientific expedition reached the site for nearly 2 decades. This delay allowed many clues to simply wash away with time. In 1927, a Russian mineralogist named Leonid Kulik led the first official expedition to the site. He expected to find a giant iron meteorite and a massive crater. Instead, when he arrived, he found a scene of total devastation, but no crater. Millions of charred trees lay flat, pointing away from a central point. Kulik mapped the fallen trees and noticed a strange butterfly shape. The trees at the very center of the blast were still standing, but they were completely stripped of their branches. They looked like a forest of telephone poles. This indicated that the blast occurred directly above them in the air. Modern physics explains this phenomenon as an airburst. An incoming cosmic object did not actually hit the ground. Instead, the immense pressure and heat of entering the atmosphere caused it to explode high in the air. This created a powerful downward shockwave that flattened the forest. Calculations suggest the object entered the atmosphere at a speed of about 20 kilometers per second. At this incredible velocity, the air in front of the object could not compress fast enough. The air heated up to tens of thousands of degrees. The extreme thermal stress eventually tore the body apart. For decades, scientists debated whether the object was a stony asteroid or a comet. A comet, being mostly ice, would easily vaporize without leaving large fragments. However, modern computer models suggest a comet would have disintegrated much higher in the atmosphere. This makes a stony asteroid the leading candidate. Researchers estimate the asteroid was roughly 50 to 60 meters in diameter. While that sounds relatively small compared to the asteroid that killed the dinosaurs, its kinetic energy was massive. It released about 10 to 15 megatons of energy. That is equivalent to a modern thermonuclear weapon. In the late 20th century, researchers found tiny silicate and magnetized spherules in the peat bogs of Tunguska. These microscopic glass beads are rich in nickel and iridium. These elements are highly abundant in space rocks but rare on Earth. This discovery provided concrete physical proof of a cosmic origin. In 2013, a team of scientists analyzed peat samples from the blast area. They found microfragments of a mineral called lonstellate, which forms under extreme pressure. This mineral is often found inside carbon-rich meteorites. This study strongly supported the theory of a stony asteroid impact. Before these discoveries, several wild theories attempted to explain the blast. Some suggested a tiny black hole passed straight through the Earth. Others proposed a chunk of antimatter collided with our atmosphere. While creative, these ideas lacked any physical evidence to back them up. One popular science fiction theory claimed a nuclear-powered alien spacecraft exploded over Siberia. This idea gained popularity because the standing trees resembled the damage from nuclear blasts. However, extensive radiation surveys of the area found no unusual isotope levels. The laws of physics point back to a natural cosmic event. In the late 90s, an Italian research team proposed that Lake Chico might be a missing impact crater. The lake is located about 8 kilometers from the blast epicenter. It has a strange funnel shape that is unusual for Siberian lakes. They suggested a fragment of the asteroid survived the airburst and hit the ground there. Other scientists remain highly skeptical of the Lake Chico theory. Core samples from the bottom of the lake suggest it is much older than 1908. The sediment layers do not show the expected signs of a violent, recent impact. Most researchers still believe no large fragments survived the blast. We actually saw a smaller version of this event in 2013. A trendy 20-meter meteor exploded over the Russian city of Chelyabinsk. That airburst shattered windows and injured over 1,000 people. It gave scientists real-time data on how these atmospheric explosions behave. The Chelyabinsk event confirmed that airbursts are highly destructive even without a ground impact. The blast wave travels outward and downward, losing energy as it spreads. In Tunguska, the blast wave was strong enough to flatten 80 million trees. It covered an area of over 2,000 square kilometers. If the Tunguska asteroid had entered the atmosphere just 4 hours later, it would have destroyed the city of St. Petersburg. The loss of life would have been catastrophic. Instead, because it hit a desolate forest, there were only a few reported casualties. It was a lucky escape for humanity. How often do these Tunguska-sized impacts occur? Astronomers estimate that objects of this size strike Earth once every few hundred years. This means we are statistically due for another encounter. However, space is mostly empty and our planet is covered by vast oceans and deserts. Today, space agencies around the world actively track near-Earth objects. Programs like NASA Planetary Defense Coordination Office scan the skies daily. They search for asteroids that could pose a threat to our planet. We are no longer as blind to the cosmos as we were in 1908. Systems like the Asteroid Terrestrial Impact Last Alert System can detect smaller asteroids days or weeks before they arrive. This gives authorities enough time to evacuate potential impact zones. While we cannot stop every asteroid yet, early warning systems save lives. It is a major leap forward in planetary safety. We are also developing ways to actively deflect incoming space rocks. In 2022, NASA successfully crashed a spacecraft into an asteroid during the DART mission. This historic test proved we can alter the orbit of a celestial body. It shows we have the technology to prevent a future Tunguska event. Amateur astronomers also play a crucial role in tracking these objects. They spend countless hours observing the night sky with personal telescopes. Their observations help refine the orbits of newly discovered asteroids. This collaborative effort makes our planetary defense network much stronger. Our atmosphere is our first line of defense against space rocks. Every day, millions of small meteors burn up harmlessly high above us. Only the larger, denser objects manage to penetrate deep enough to cause damage. The Tunguska asteroid was just large enough to bypass this natural shield. The Tunguska event taught us that the solar system is still a dynamic and violent place. It reminded humanity of our vulnerability to cosmic threats. The scientific study of this event has shaped our modern understanding of impact physics. It has turned a historical mystery into a vital field of science. Today, the blast site is a protected nature reserve where scientists continue to study forest recovery. The trees have grown back, but the scars of 1908 are still visible in satellite imagery. It remains a powerful monument to the raw power of the cosmos. It urges us to keep looking up and preparing. We hope you enjoyed this deep dive into the Tunguska event. If you found this cosmic history fascinating, please like, share, and subscribe to Cosmic Earth. Your support helps us bring more science stories to life. What cosmic mystery should we explore next? Let us know your thoughts in the comments below. Do you think we are fully prepared for the next big asteroid? We love reading your theories and ideas. Thank you for watching, and we will see you in the next video.